So before we dive into the mechanics of solving logarithmic equations, I want to stop for just a minute and talk about the definition of a logarithm. And I don't want to go too deeply into this because logarithms aren't our topic, right? Solving logarithmic equations is. But this definition is a key component of the process for solving an equation that has logarithms in it. So the way a logarithm is defined is we say y is equal to the log base a of x if and only if x is equal to a to the y power, right? In other words, these two equations are equivalent. If one of them is true, then the other one must be true. So let's see how this works, because the thing we really need to be able to do is take a logarithmic equation and rewrite it in the equivalent exponential version. Right, so let's say I have an equation like 4 is equal to the log base 3 of x. And I want to rewrite this in the exponential form. Right, the first thing I want you to notice here is that in both versions, the bases are the same. Right, so over here on my left, on my logarithmic equation, the base is 3. So the base in the equivalent exponential version will also be 3. Right, now the next thing I want you to notice is the other two parts of the equation have switched sides. The number that was on the left side over here is on the right side over here. And the number that was on, or variable in this case, the thing that was on the right side over here in the logarithmic equation is on the left side in the exponential equation. So that's what I'm going to do for the next two parts. I'm going to take the 4 that's on the left side and make it the exponent on the right. And I'm going to take the x that's on the right side and move it over to the left. And that's it. There's the equivalent exponential version. We can simplify this one a little further, right? 3 to the 4th, that's 81. And we're done. And I want you to look at what we just did right here, right? Because we just solved our first logarithmic equation. I took this equation over here, and I manipulated it, and I rewrote it in such a way that it looks like x equals a number, right? I solved the equation, doing nothing more than applying the definition of a logarithm, right? So let's look at another example. Take a look at this thing. Log base 4 of x equals 2. How can we solve this maybe a little quicker without resorting to really trying to match up the pieces? Well, remember what I said. The bases stay the same. So the base of the logarithm is 4, so the base of the exponential version will also be 4. And then the other parts, the 2 and the x, change sides. So the 2 goes over here and becomes an exponent. The x goes over on the other side. And that's my answer. X equals 16. Right? Just applying the definition. So how about this one? Right, I've got the ln of x, the natural log of x is equal to -1. Well, the first thing, the reason I picked this one out, students sometimes see this one and they mistakenly jump to the conclusion that there are no solutions because they say to themselves, the logarithm can't be negative. Well, yes, it can. The logarithm of a number can be negative. What they're thinking and kind of misapplying here, you can't take the logarithm of a negative number. So if I'm doing my business here and I come up with a negative value for x, that would be an issue. Right? Then I would have to first go back and double check my work. And if it turns out it was right, I would have to discard that answer. Right? But the logarithm itself, yeah, absolutely this can be negative. There's nothing wrong with that. Right? So when you're doing these, you know, there are two logarithms where we don't usually write the base. Right? This ln is the log base e, and we also have this one here. That's the so-called common logarithm, or the base 10 logarithm. If you just kind of know that and you can jump right to the answer, that's fine. If you need to write it out, That's okay too. Or you can rewrite this, the log base e of x equals -1. If you need to explicitly see it, that's okay. Now I'm just going to apply the definition again. The bases stay the same. The -1 goes from the right side over to the left and becomes the exponent, and the x goes over to the right. And that's almost the answer, right? We don't usually write it like that. I'll flip this around and write it x equals e to the -1st. That's perfectly good. I would accept that as an answer. You could also simplify that negative exponent and just make this 1 over e. In my classes, I would take either one. All right, so that's how we handle basic logarithm equations, equations that have only one logarithm in them. In the next lecture in this series, we're going to take a look at a slightly more complex case and look at how we can solve equations that have 2 or more logarithms.